All right, so let's do some of these problems together, okay? So first of all, it says show all of your work or no credit. Guys, I don't want to, I can't, this is going to sound like math class. I can't figure out what's in your head. I can only figure out what you've got written down on paper. So write it all down, show your work. Don't take the easy way out, because if you get stuck, I can't figure out where you are, okay? So, make sure that you are showing all your work, do step by step, and then you also have some practice and some guides for you when we put this in the practice for the lab we're going to do. And then also I want you to round all answers to two decimal places. All right, there were two formulas that asked you guys to put in your noggin and to remember. So the first one is going to be P plus Q equals 1, or 100% of the population. The second one is P squared plus 2PQ plus Q squared equals 1, or 100% of the population. All right, so in question number 1, it says the frequency of a dominant allele is 0.56. I flipped that. Is 0.65. Okay, so that dominant allele is going to represent P. Okay, so what's the frequency of the recessive allele? So as we remember, P plus Q equals 1. So we've got 0.65 plus Q equals 1. So that tells us that that's going to be 0.35. So what is the frequency for homozygous dominant? Well, homozygous dominant is going to be P squared, which is going to be 0.65 squared. And that gives us 0.42. Okay, what is the frequency for heterozygous? That is 2PQ. So we've got 2 times P, which is 0.65. Always put the zeros in front, no nicking numbers. Your chemistry teacher will thank you next year if you always put zeros in front. So 2 times 0.65 times 0.35. And that gives us, yes, you can calculate this too and not wait for the answer, 0.46. And then homozygous recessive is going to be Q squared. And our Q squared, so remember this is going to be our Q. So Q squared is 0.35 squared. And again, you can calculate this. You don't need to wait for my answer. But it is 0.12. Now, we can always double check. Guys, the nice thing about this is that we can double check because, well, this equation should equal to 1. So if we put that and we add those together, so if we add up 0.42 plus 0.46 plus 0.12, well, we've got 6, 7, 8, 9, 10. Carry the 1, 8, 9, 10. Carry the 1, we've got 1.00. So that means we should have done that correctly. Okay, so we're done with that one. Number 2, it says in fruit flies, normal wings are dominant to stubby wings. In a population of 1,000 flies, 400 show the recessive trait. So remember, this is what we need to start with. So 400 show the recessive trait. That 400, the recessive trait is a little a. So eventually we're going to figure out what the frequency of that is. So 400 equals the little a. So the first step is to take that 400 divided by 1,000, which is our total population. And that's going to give us 0.4. And so if little a is what that recessive trait is, that's going to be that Q squared. So 0.4 is Q squared. Okay? So now we can kind of begin to go through this. Q squared, let's go ahead and get Q. So Q equals square root of 0.4, and that gives you 0.63. So then it says, what is the frequency? So letter A, what is the frequency of the recessive allele? So there we're just looking for Q. Well, we just figured that out, and that is 0.63. And then the dominant allele for B, what's the frequency of the dominant allele? So P equals 0.37. And then you can continue to go. So letter C, what is the frequency of homozygous dominant? Well, homozygous dominant is going to be P squared. You can calculate that. And how many of the homozygous dominant individuals are there in that population? So you will take that number and you will multiply that by 1,000. So that number times 1,000, and that will give you the number of that population. Letter E, what is the frequency of heterozygous? So remember, heterozygous is 2pq. That'll give you a number here. And then how many heterozygous individuals are there in the population? So again, you will take that and you will multiply that by 1,000, and that will give you your number there. Okay, and I'll let you guys finish calculating those. And I am going to get you started on number 3. All right, so in flowers, red is dominant to white. In a population of 1,000 flowers, 970 show the dominant trait. So guys, remember that dominant trait, we cannot start with that because that's going to have big A, and, not really or, and big A, little a. So it's a combination of dominant and recessive alleles. So we're going to need to first now take our 1,000 flowers minus 970. And so we've got our 30 recessive. And we want to start with that because we know that that's going to be little a, which is going to be your Q squared. Okay, and from there you can now go and answer these questions. Okay, so the frequency of the recessive allele is just Q. Dominant allele is just P. Heterozygous is 2pq. Homozygous dominant, so that was going to be Q squared. Heterozygous individuals, 2pq. And that's in the population, so you'll take that number and times it by 1,000 on both of those. Because that was with how many. So here's basically back to the frequency of homozygous. So now we've got our Q. Whoops. Let me go back because homozygous dominant should be P squared. Okay, and then this should be Q squared. Okay. And then how many of those individuals? So you'll take this number here, multiply by 1,000 to get that number. All right, you are on your own for the most part on the next questions. Guys, always remember, if it gives you the dominant trait, you've got to figure out the recessive and go from there. If it gives you the recessive, you're good. We got to start with recessive because we know it's pure, little a, whereas the dominant is not. Okay, work through the rest of these, show your work, write everything out, and ask for questions if you have them.